AP Calculus AB. Here's a couple other ways to use substitution, and just want to continue to remind you that you have to prepare yourself to see a lot of patterns on the AP exam. So here's this thing that just looks a mess, and it's hard looking at this to figure out how you're going to find this indefinite integral. And what I kind of want to remind you is that look for some piece of commonality. So here's this x plus 1 here, and here's this x plus 1 here. So I think what I'm going to do is this. I'm going to let u equal x plus 1. And then I'm going to go ahead and take the derivative du dx and solve and get du is equal to, right, the derivative of this is 1, so it's equal to dx. So dx is equal to du, if you don't mind. So look what that gives us. Oh my God, it gives us, well, let's look. Look what it gives us. It gives us this. It gives us opposite x over, look, x plus 1 is equal to u, so it gives us u, doesn't it? Minus square root u dx. Now, of course, I can take out the dx and put in du because dx is equivalent to du in this case because we solved that out, didn't we? And it looks pretty good. The only problem I'm having now is this one, that I don't know what to do with this x up here. And when I looked at the derivative, there was no way, if you've seen the other videos, that a lot of times we'll see something where we'll have dx, du over something, then it cancels out something and it gives us what we're looking for. And I want to remind you that what we're looking for is this, f of u du, because from there we know we're free to integrate to get parent f of u plus c. So we're going through our steps to be able to finally integrate here. So it didn't work very well. So this is all I'm going to do here. I'm going to solve for x in terms of u. So what am I going to solve for this? And when I solve this for x, I'm trying to get this x value here, trying to get this x value right here. If I solve, I find that I get x is the equivalent of u minus 1. And all I did was some algebra here, negative 1 here, and got x as that. And you may not be horribly impressed with this, but you will be in a second, because the problem I'm having here is I'm hung up because I have a variable x and variables u. And if I can replace this x value here with a u value, and I'm going to, it says x is equal to this, I'll take this value out, and I'll put in is u minus 1. Right? And from there, I'm actually pretty happy. And then it starts to unfold a little bit, and I don't know how to say this to you in a better way than to just start playing around and seeing what you get. So what I'm going to do here is I'm going to leave this opposite u minus 1 at the top for now. But this piece at the bottom, I'm going to factor the greatest common factor. And I hope that you can see this, because the greatest common factor of this thing is square root u. And it's the square root of u times the square root of u minus 1. If this is bothering you, look, this is square root of u times square root of u is u. Square root of u is u to the 1/2 power. Square root of u is u to the 1/2 power. And if you remember, if we have like bases, then we add the exponential values. So that would give us u to the 1/2 plus 1/2, or u to the first power. So this will factor out, right? So if it's true this way, it's true that way. And here's my du. From here, you have to really start paying attention. And what I'm paying attention to right here is this. I'm wondering down here, this looks like crap down here. So what I'm wondering is, are they giving me something that I'm not seeing? And I believe that they're giving me, I believe that this is a factor of this. And this gets to above intermediate algebra, that you really have to be able to see this, because if you were in algebra class, I'd be hard pressed to convince you that u minus 1 is the difference of squares, but it is, because the square root of u minus 1, and 1 is a perfect square, and times the square root of u plus 1 is equal to this bit right here. And why is that significant? Because look what they gave us, right? So I'm going to take difference of squares here. This is difference of squares. So I'm going to replace this. And if you look, this times this is u, isn't it? This times this is positive square root of u. This time this is negative square root of u, so they'll cancel each other out. And then negative 1 times positive 1 is this negative 1 again. So I'm going to replace this crap here. And I'm going to replace it with square root of u minus 1, and you see what it's on top of now, square root of u plus 1, close those parentheses. Okay, so now this is what I'm going to do. Just for sake of convenience, I'm going to start doing some other calculus here. I'm going to claim that this negative 1 right here, this is a negative 1, isn't it? Sorry, this is a negative 1 right here, isn't it? Negative 1 is our constant multiplier. This negative sign is our constant multiplier. So I'm going to pull it out. Here's my negative 1. There's that. And I'm just going to rearrange these a little bit. And I'm going to take this u over u minus 1, square root of u minus 1 here. And put it over this one here. And get this square root of u minus 1. So I'm going to take those as factors. Right? Times square root of u plus 1 all over square root u du. This is really a lot, isn't it? But look, this is going to come together really well. These are factors, so square root of u minus 1 over square root of u minus 1 is a factor of 1. So 1 times this bit right here is just that piece, isn't it? So that cancels itself out. And then I'm going to go ahead now and partition this piece out. Isn't it true this is the same as u over square root of u plus 1 over the square root of u? And that will look like this. Square root of u over square root of u is 1, isn't it? And 1 over the square root of u is 1 over square root of u. Isn't that true? du. Wow. Believe it or not, we're actually really getting here. We're getting to where we're going. We truly are. Because I can rewrite 1 over the square root of u as u to the negative 1/2 power. U to the negative 1/2 power. And I said at the very beginning of the video that our goal is to get to the indefinite integral of f of u du, because we know that that confirms to us that we can integrate into this form right here. So I'm saying to you, this is f of u is a composite function that looks like this, and there's our du. So we have this, and our negative 1 is our constant multiplier. So here we can finally do what we do, which is to integrate. All right? So when we integrate this, I'm just going to take this negative 1 here and I'm going to put it outside. And the first integral of 1 is u plus, so we have u to the negative 1/2 plus 2/2 is u to the 1/2, right, over 1/2. And I can bring this up as 2, isn't that right? So 2 here, right? Plus c. And oh my gosh, how does that make you feel? So from here, is there anything left that we should really be doing? And I kind of like it. I really do. Of course, we have to go back now and resubstitute, which is, gosh. So we have to resub now, right? And remember that we let u equal x plus 1. So remember that u is equal to x plus 1. So I have to go back to all these u's like this, and I have to resubstitute. That's what I'm doing here. So u is x plus 1. So I have x plus 1 plus 2 times the square root of x plus 1 plus c. And there's somebody in my AP class right now saying, should you really distribute that negative sign to the c? And it doesn't matter. Why does it matter? Because it's a constant. But it makes you feel better, Jack. There, buddy. All right? And is there any... Oh, look at this. Look at it. This always freaks everybody out. This will freak you out in the AP exam. Look what happens. We get this here, right? And this is going to turn into x plus, isn't it? Plus 2 times square root of x plus 1 plus 1 plus c. And this is absolutely ridiculous. And I agree with you. This should actually be a negative 1, shouldn't it? Because if I distribute this all the way through. But look, it's a constant, so it's just c, isn't it? And if it makes you feel better, I'll add 1 to c and make it c sub 1, the other c value. And there's our answer. Wow, right? So let's go back just for a second. If you're still with me, I can't tell you how much I appreciate it. And I really want to go back, and what I want to make sure I've said to you is this, that you're going to see tons of patterns on the AP Calc AB exam, and you're just going to have to be able to see what you have. Here, I don't know where to start, and I'm being sincere with you. I'm like, where the hell am I going to start with this mess? But I see this recurring x plus 1, and I'm like, you know what? If I let x plus 1 equal u, this bottom, the denominator here, will simplify out pretty well, won't it? And that's how I got my start on it. I don't think that this numerator is the derivative of the denominator. If I did, then I might go about this in a different way. I might check and see if this is an ln function. I hope this is making sense to you, and I hope that this is really helpful to you. If it is, please let me know. And if it's not, tell me what you think I can do better. I hope that you have subscribed to my channel. If you haven't, I hope that you will. And if you want to follow me on Twitter, that would be great. And you can follow me at C Lindelof. One word, C Lindelof. And I appreciate it, and I'll do what I can. So good luck, and keep up the good work. It's going to take some practice.